Hi everyone, are you able to hear me and see my screen clearly? Great, great. All right. So for the question answers, you can use the Q&A window. That will make it easier to answer the questions, as well as for, all right. So basically for question and answers, use the Q&A window and use the chat window for your general introduction. Manoj, can you hear me? The audio is audible to others, so kindly check your audio settings. Great. Welcome all to the introductory session on big data. The total duration of this session is 3 hours. In the first half, we will talk about the general introduction of big data. And in the second half, we will discuss Hadoop and Spark architecture. This session is being recorded, and the recording and presentation will be shared. Everyone except me is muted. So please ask your questions by typing in Q&A window. I will read out the questions before answering, and to get better answers, keep your messages short and avoid chat language. All right, since this first session is, there are larger audience, therefore everyone except me is muted. From the second session onwards, since there will be a smaller class, you will be able to chat, and occasionally if you are not able to get your question through by typing, you can also unmute from the second session onwards, but that is very exceptional. All right, because there are quite a few people in the class. The other advantage of typing the question instead of instead of instead of speaking it out is that you will be able to ask questions whenever you get the question in mind, instead of waiting for me to finish and then ask. All right, great, great. All right, so these sessions are very question and answers oriented, and the aim is to keep the discussion going instead of turning off the discussion and going in a one-way mode, as in only the instructor talking. It is basically to help you learn big data and the entire technology stack. Therefore, please ask your question as much as possible. All right, do not hold back your question, because your question is not stopping others in the class. Instead, it is actually helping others because they might be having the same question. All right, so please ask your question as soon as you get it in your mind. All right, so do not hesitate in asking question. That's what I'm trying to say. All right, now coming back to the session. So I'll be the instructor for this course. I'm Sandeep Giri. I did my graduation from IIT Roorkee, and then I have largely worked on the large scale computing. I started my career at the Isha, where we had a 10,000 node cluster. Then I worked with InMobi, where we built a recommender using 200 terabyte data. And then I worked with Amazon, where I worked with detail page. So at heart, I'm a software engineer. and I love explaining technologies. And because there was a need of organization or there was a need of teaching the big data technology in the market. So we started CloudxLab. The aim is to make the learning really gamified, as you will see in the upcoming sessions, that you'll be able to learn in a very engaging manner. Instead of trying harder to focus, the course is designed in order to engage you end to end. All right. So the aim at CloudxLab is that we want to make learning gamified. So as part of the course objective, this is the first session of the course. This course is really huge course in the sense that there will be around 20 sessions, 10 dedicated to the Hadoop stack, while approximately 8 to 10 sessions dedicated to Spark. All right. So the objective of this course is to learn big data with Hadoop and Spark, along with all the related technologies. The course is structure along with our live course, we provide you a studio recorded course in which the structure is that there are videos, there are quizzes, there are hands-on assessments, and there are projects along with the case studies. So the idea is that all of these are built around real life use cases. The unique proposition from CloudxLab is that we provide the automated hands-on assessment, meaning it challenges you to do something in the lab, and then you have to log into the lab and solve those challenges, and then it rewards you. That's what is automated hands-on assessment. All right. The idea is that you get a problem statement, then you have to log in into the lab and do the hands-on, and then it assesses you and gives you the rewards. Okay, this is an example of the same. That here the challenge given to the end user is to log in into CloudxLab, and only when the user actually logs in, this evaluation will be successful. All right. So along with the live course, you get the self-paced course. If you are only interested in self-paced, you can go ahead and take the self-paced course separately. And under my course, you will get the courses. In the courses, you will get the list of all the technologies. Okay. This is called learning item, and a learning item could be any of these. All right. So let's start with our usual session. Okay. So welcome all to the session. I hope you will have a good time with the session. Keep asking your questions as much as possible. Great. All right. So feel free to introduce yourself in the chat window. That way, we'll be able to understand your background and can suggest you better advice. Okay. So again, today's session is 3-hour session from 8 to 11 IST. And in this session, there are close to 60 people right now. And in this session, we are just going to go over big data, Hadoop, and Spark Stack. This is a very basic session because for this session, the audience is a, a larger audience, people from various backgrounds. So This session is for almost all kinds of backgrounds. Therefore, do not worry about too much technology. We do not, this session does not require any kind of technology background. Great. All right. So before we start with our rest of the discussion, let me just define few terms. These terminology will be useful as we go ahead. Okay, great. Great to have you, Subham, Mallikarjun, Sanjay, and Jayanti, Hitesh, Pugal, Tulsi, and Manoj in the session. Welcome again. All right, so let's start with our first definition that will be needed again and again. The first definition is data variety. What is data variety? Or what are the kinds of data that we talk about in the upcoming session? Okay, so data is largely classified as in three buckets: structured data, semi-structured data, and unstructured data. The data in which you clearly know the number of fields as well as the, the data type of each field. It's called structured data. Structured data is also mostly in the form of tabular structure. So the data in your MySQL databases is structured data. And then there is unstructured data where we neither know the columns, we do not know their data types. In midway between structured and unstructured is semi-structured data. Semi-structured data means we know the fields, but we do not know their data types. Say, for example, the data in CSV is semi-structured. All right. So this is a large classification of the data. Now, to translate unstructured into structured is called ETL, extract, transform, and load. There are many frameworks of ETL, including Informatica and others. In case of big data, ETL is really a big problem. And ETL is something where most of the big data engineers and data architects spend a lot of time. All right. So mostly the life of a data engineer is around this kind of data. Now, the second term that you will hear a lot in this course is distributed systems. What is distributed systems? Distributed systems means groups of networked computers which are interacting with each other in order to achieve a common goal. In order to achieve a common goal. That's what is distributed system. The important thing here is the multiple systems are trying to achieve a single goal, right? Let's say you want to process a data for solving a problem. So you are trying to use multiple computers to solve your single problem. That is distributed systems. Distributed systems does not mean that the systems are just connected, right? In a computer center, you have the network, but that's not a distributed system unless you utilize all these computers to solve a single problem. All right. So this is distributed system. So we will learn about distributed system as we go ahead. And Big data is largely about distributed systems. So all the tools that we learn in this course are around distributed systems. So any tool that we talk about in this course will be able to run distributively on multiple computers. All right. Okay, just to check if everybody is awake. So how many bytes are there in 1 petabyte? Yes? Right, right. I got my first answer. Good, Vijay. So there are 1024 terabytes in 1 petabyte, and 1 terabyte is 1024 megabytes, and so on. All right. Or if you count in terms of bytes, it is close to 1 into 10 to the power 15 bytes in 1 petabyte. So 1 followed by 15 zeros, those many bytes are there in 1 petabyte. All right. Another trivia, how much data does Facebook store in 1 day? Yes? How much data does Facebook store in 1 day? Subham says 1 petabyte. I see. Tulsi, I would like to connect you personally. All right. So feel free to reach out over the email. Great. So yes, you're right, Hitesh. So close to 600 terabyte data is what they're storing in 1 day. All right. So that's a huge data that they're storing in 1 day. Now, question to you is, what is big data? What do we understand by big data? Yes, anybody? Just first answer will be sufficient for me. What do you understand by big data? All right. So Hitesh says large volumes of data. My question is, how large? How big volume? Dharma says 4 Vs. And more than terabyte, Janti says. Good, good, Manoj. So Manoj's point is large amount of data which is too big to be handled by traditional RDBMS. All right. So not only RDBMS, even the file system. Let's take a look at. Big data is nothing but data of very big size. How big? That cannot be processed using usual tools. What kind of usual tools? Your usual tools like file systems or relational databases, that kind of usual tools. And in order to handle big data, we would need multiple computers to solve our problem in a reasonable amount of time. All right. And how do we use multiple computers? We use distributed architecture. All right. So the data of very big size, which cannot be processed with usual tools, and we require distributed architecture to handle such data. That data is called big data. All right. This data could be structured, semi-structured, or unstructured, not necessarily the structured data in the databases, but also unstructured data in the form of files or semi-structured in the form of the various other formats. All right. So this is the definition that we are going to stick to during the entire course. So this course is about studying various distributed systems and learn how to use these distributed systems in order to solve our big data problem. That's what we are going to learn as part of this course. Today's course is around big data, the general definition and annotation, but session 2 onwards, it is more technical. Session 2 onwards is more hands-on, and it is very much oriented towards the practical applications of big data computing. Great set of questions. Keep the questions coming, and you can utilize the Q&A window. Is Q&A window visible to you? That makes it easier for me to answer. And you can also you can also see the questions. Great. All right. So that's the definition of big data. Now, the general characteristics of big data is classified into these 3 V's. I'm avoiding the 4th V because there is no limit to adding V's. You will get a very clear picture just by these basic definition. So we talked about big data, and we said that not only big data, but any data has the basic, any data could be in any form. Either it could be tabular, it could be non-tabular, it could be like a movie, it could be like a complex structure in the form of map, right? So when we say handle the data, what does it mean? It means we are talking about 3 things. We are talking about storage. We are talking about the data that's coming, flowing, and we are talking about processing the data, storing, storing, handling the requests, and processing, right? So these are the 3 characteristics of big data. The first one is volume. First one is volume. What does it mean by volume? Where when the data is huge, it becomes impossible to use the traditional systems. So the problem that arises due to volume is say for example, you have a website and you're generating the logs. What is logs? When a request comes from the user, it is recorded somewhere in a file, and that file is called logs. So or so the website, when it stores all the information that's coming all the time from the users, that logs could become really big. Similarly, if you imagine how much data would Gmail would be storing, right? So and how much data would Facebook be storing? So the volume, when it becomes bigger, you cannot really use a normal file system to store the data, or you cannot use the usual relational database to store that kind of data. All right. So first characteristic of data is volume, and this is first signal that if you can't handle the volume, you won't be able to handle anything else. All right. So the second characteristic of the data is velocity. What is velocity? The data in motion. For example, when you access Facebook, there are requests going to the Facebook. Now imagine how many requests are going to the Facebook when billions of users across the globe are continuously pinging their servers. So billions of requests are going to Facebook every second, or you can say hundreds of millions. All right. So the velocity is another problem to the server, because how would you handle so many requests coming from the user. Third is variety. Variety means the data in many forms. Also, variety also means that the translation of data in various forms, or processing of data in various forms. So variety, the, the third V also means complexity of a problem. Say, for example, you have a map of a country and you would like to go from one point to another. You would like to go from one point to another and you would like to find the path that's fastest, or you would like to find the route that's fastest to reach from A to B. And to do so, you will need a lot of computation, and the problem is complex. Therefore, handling a data structure like a map, handling the data in the form of map is complex. So the variety introduces the complexity of computation. Similarly, generating recommendations, doing machine learning, doing all kinds of intelligence on top of data requires computation. So the third V, the variety, also is one of the important characteristics of data. And either of these three V's, either of these three characteristics could push your big data problem, could push your data problem into big data problem. All right. So you're not able to handle volume, you're not able to handle velocity, or your system is not able to handle velocity, and you're not able to handle variety, you will have to move to big data. You'll have to use the big data tools. Now, here's another question. This is something that you can search also. Okay. Question is, how much time does it take to read 1 TB from hard disk? HDD means hard disk drive. Your computer has hard disk drive. Right. Have you tried copying 1 TB movie from one computer to another? Let's assume here the speed of hard disk drive is usual. So it would minimum take around 6 hours. All right, around 6 hours. It could be, if your hard disk is a little more costlier, you could get faster speed, maybe to 5 hours, but nothing below that. Yes, thank you, Manoj. His point is that it may also depend on number of files, right? So this is kind of the minimum time taken. If you have many number of files and you have many mm, kind of data located at various locations on the drive, or how are you reading, it might take more time than that. All right. So this is just a this is a good estimate I wanted to give you, that to read data of 1 TB size from hard disk, it takes minimum of 6 hours. All right. Before I jump to next question, let me answer Hitesh's question. Hitesh's question is, have much, if data does not have much variety but is large in volumes, then can it be called big data? Yes, yes, because When the data is huge in size, you cannot really store it in a single computer, and you would need distributed architecture or distributed systems in order to store humongous data. This is where Hadoop distributed file system comes into play, that data may not have much variety, but but data is just in files, maybe in CSV files, and is stored there. Or let's take another case. Let's say your data is in only in tabular form and it's going beyond few terabytes, or say few hundred terabytes, then your traditional relational databases will not be able to handle it. And therefore, you would require distributed architecture. All right. Another question is, but if data has more variety, velocity, and less volume, can it be called big data? Good question. Good question. So the point that velocity, I'll give you these are very good questions. Let me give you a couple of examples of all of these. Let me give you a scenario in which there is no volume, but there is a high velocity. Imagine that you are running a web service or a website, right? And let's say Facebook kind of a website. And people are just checking your website continuously, right? Now, in that case, let's say your website is just read only. It is not expecting any data from the user, right? Any data from the user. You're not expecting any data from the user, and you're only storing the user's widgets, that how many users are visiting you every second, right? So when a user is visiting you every second, you're just increasing a counter. So counter is the only thing that you are keeping with you, right? So the volume is really low, right? You're just storing a very small data. But if your website gets just too many hits from all over the world, right? You won't be able to handle this. Not you won't be able to handle you won't be able to handle such a traffic using a single system. And in order to keep the counter accurate, you will have to build a system such that even though your website is hosted on multiple servers, you should be able to count the number of widgets accurately. And this is where the big data systems would come into play. So even if the velocity is low, even if the volume is low, but the velocity is high, you would end up with big data architectures. You will end up using big data systems. Now, the second question, that can there be variety when there is no volume and no velocity, right? So the example that I gave you about the map, a map is not huge data, maybe 100 gigabytes data of a country, but that 100 gigabyte is easy to handle from the volume perspective. You can easily handle 100 gigabyte data, right? 100 gigabyte is nothing but like 25 movies. That's not a big deal. So the variety comes into play here, that even though your volume is 100 gigabyte, but processing a map of size of 100 gigabyte would take a lot of computing, would take a lot of computing. All right. And that's where you would require big data systems. A question from Subham is, if data has any of three characteristics, then it can be called big data. Yes. Great set of questions. Keep the questions coming. I hope everybody is in sync with the question answers. A question from Afghan is that so processing or preparing a lot of data requires big data. So it doesn't require big data, it requires big data architectures. Big data is the data that a lot of data is called big data. All right. So processing or preparing a lot of data means big data. Yes. When you cannot do that processing using your usual systems, then we call it big data processing. All right. Question from Bindu. Can you give practical example of the three? Yes. So the practical example is that when you are trying to store a lot of data in your organization, maybe you are downloading data from, say, Twitter, or you are generating your internal data, your website logs, that data is big data, the volume. All right. So volume could be because of the size of the data, right? Now, the data could be from your, let's say you are working in a financial organization, you are reconciling a lot of records, and therefore the data could be in many form. Data could be of many kinds. Now, the second one that we are talking here is the velocity. The velocity. Velocity means velocity means here the number of requests that are coming or data transport that's happening, right? For example, you are around 80 people connected right now with the webinar, and the video that's coming from my side is getting distributed to 80 people. Okay, getting distributed to 80 people. Now, to handle this kind of transport, to handle this kind of velocity, you would require a big data architecture. Third one is the variety. Variety A could be because of the complex situations. Let's say you are trying to build a recommendation system. Recommendation systems are complex. Every record processing takes a lot of time, and therefore, if there are billions of records to process, it'll take further more time. Okay, so I hope that gives you the answer. The third example is finding way from one point to another in a map, or preparing a social graph, as in finding the friends recommendations, given the graph of friends, and so on. Question is, what's the difference between cloud and big data? Cloud is nothing but computer in somebody else's premises, while big data is humongous data. All right. So big data architecture or distributed architecture is network of computers that are being used to solve a problem. All right. Okay, I hope that answered your question. Question from George is that what is big data exactly in an architecture or a technology? Big data is just a term to signify the data, huge data. Okay, well, big data architectures are those architectures which can handle humongous data, all right, in order to achieve the goal in a reasonable time. Okay, so big data architecture is a distributed architecture. So big data systems are technology, while big data is just big and data. Question from Bala is that what are the qualities should a big data architect should possess? Okay, in very simple terms, a big data architect must know basics of Linux, must know SQL, must know the one of the any programming language, plus big data architect must know about Hadoop and Spark systems, right? They should know the distributed architectures, various distributed architectures available, and big data architect should be able to make a decision which tool to use when. What is the name of the system that stores big data? Like normally we use MongoDB or SQL. So MongoDB is a big data storage. We will discuss this part after a while. All right. Very good set of questions. Keep the questions coming. Now, here is a question for you. Question is, if you have to count just the vowels in 1 petabyte data every day, do you need distributed system? Do you need distributed system, or you can use the existing RDBMS or your existing programming? If you just have to count vowels in your data, and your data is say 1 petabyte data, and you have to do this every day, do you need a distributed architecture? Do you need more than one computer to achieve this? Or you can achieve this using a single computer? Okay, so Chirag's point is that we can use it using supercomputer. Facebook is doing it. Not really. Nobody is using the supercomputer there. Everybody is using the distributed architecture, the big data architectures. All right. So Facebook is doing this kind of work using the big data architectures. All right. And the other misconception is if we have a single computer with good memory and CPU RAM, we can achieve this. The answer is no. No matter how fast your computer is, you cannot speed it up. And the answer is here. The time taken to read the data from the disk is huge in case of 1 petabyte, and you cannot really achieve it in a significant time. The bottleneck in most of these cases would be the time that it takes to read data, not the time it takes to process data. Okay. A question from Sarika is, what all should an architect look at who has to pull in the software algorithms or increase processing capability of microprocessors? I think this question is a little big question, and this question deserves bigger time. So I would love to answer it over our forums. So if you have a little bit of time, come over to our website's forum, and I would like to answer it there. All right. It's a big question to answer. All right. Now, coming back to it, very good point, Manoj. It is scale up versus scale out. There is a limit to scale up, but no limit to scale out. Good, good. We will study the difference between scale up and scale out. All right. Okay. All right. Now, coming back to it, when we go through these steps, we will understand that why would we require distributed architecture as we go ahead, and why now. All right, good, great. Now, this is a graph which shows the digital amount of information globally. Digital amount of information, the digital information, the amount of digital information across the globe has been increasing exponentially. Okay. Globally, the amount of data that was stored in analog storage, such as plain text files, as in the books and the libraries, the physical storages, that's going down, while the digital storage is growing exponentially. It might look like a linear graph, but in reality, it is exponential. Now, question is, why is this happening? Why so much of data is being generated and so much of need to process such data is coming in play? The answer is threefolds. The first is the devices, the globally the devices are becoming faster, cheaper, and smaller. If you talk to any of the hardware manufacturer, they have these three objectives: faster, cheaper, and smaller. On one hand, the devices are becoming faster, cheaper, and smaller. On the other hand, the connectivity is improving. The fact that the fact that so many people are attending this session right now from different part of the world shows that the connectivity has become very practical for a video conference, right? At the same time, the devices have become really faster, cheaper, and smaller. The mobile phone that you are holding right now is actually better than supercomputers of 2000s. Okay, it's actually far more powerful than any of the supercomputers available in 2000s. Okay, and so you can estimate that while on one hand the devices are becoming powerful, cheaper, and smaller, the connectivity is also improving drastically. We have Wi-Fi, 3G, 4G, near field communication, Bluetooth, GPS, and so on. And because of this, because of devices and connectivity, many applications are happening. On one hand, we are having a lot of social media. On the other hand, we are having a lot of e-commerce, and other side we have Internet of Things, meaning we are gathering a lot of information in order to take various actions via various devices. So there are many applications that are happening because of these two things: devices and connectivity. And these are the two reasons why the data is growing exponentially. A question from Gaurav: is the growth of IoT contributing to the need of big data processing? Yes, that's very right. But at the same time, the growth is more contributed by social networks. A question, let me answer a few questions. A question from Avgin is that, is becoming good in big data handling essential skill for a person working in IoT? If yes, to what extent? All right. So if the kind of data that you're going to handle tomorrow, even in IoT, in IoT, what all do you need to know? In IoT, you need to know the hardware. You need to know the hardware and how to use various sensors along with the chip, along with the microcontrollers such as Arduino or say other smaller systems like Raspberry Pi. On one hand, you need to know that. On the other hand, you need to have a central place from to which the data or the information or the service calls will be made to. All right. For the other side, if the other side where the data is being gathered, if that data that's coming from the IoT devices, if that's really huge and you're not able to handle it using single instance, you either go for the managed services like AWS, or you set up your own service, which is kind of big data service in many ways. Good question. Question from Sanjay is, if we are good at Scala, do we need Python to get into big data? Not really, not really. I think any programming language you are okay with, you can actually do most of the computing in today's time using any programming language. A question is, may I know how much data is being processed in this conference? So you can do a bit of calculation. So at the end of this session, the recording would be close to 400 megabytes, if that's what you mean, the recording part. The data transfer would be 400 into 80. All right. Though, if your question is related to, are we going to do some hands-on over big data? That we won't be doing in the first session, but in the second session onwards, we will be handling a lot of data using CloudxLab. All right. A question from Chirag, what's the difference between IoT and AI? Um, I think we can take it offline. All right, you come over to the discussion forum. I would love to answer it. This will actually take it entirely different discussion. Okay, though it's a good question, but it is out of context from this session perspective. So I would like to take it offline. All right, so Darshan's question is, when do we feel to parse the data? Okay, so question is, it's an interesting question. If you look in the details, when do we feel to parse the data? Okay, and yes, there is no right answer. The important point is that you should know that storing the data is costing you how much? Okay, in terms of, if you're okay, it's an interesting question. So in earlier times, in earlier times, we used to just delete the data because it was costing us a lot to just keep a lot of redundant data, such as older logs of systems, such as the the data of a deprecated system. We used to delete it. Or let's say customer behavior we never captured because we did not know that we could derive so much value from the customer behavior that we would need it tomorrow. Okay, so it was hard to justify the value of storing the data. So we used to just delete the data. Okay, this data lake, for example, Amazon, right? But Amazon costs you far more. So you will know when to purge the data once you know how much does it cost you in case of big data storage, as well as what kind of use case you can derive from the user behavior. Okay, there are many use cases which people find it very strange that at Amazon we did not delete the our web servers logs. We never deleted, and that's the reason we were able to give recommendations at Amazon's website. All right, so so once you know that the storing humongous data is not costing you too much, and you can derive all kind of relationships, and you can convert the historical data into money, into revenue, then you will know when to parse the data. A question from Manoj is, how is the language chosen? Okay, let me answer this question because this question would come from other people as well. Okay, so from this session perspective, I'll keep myself very confined to this session perspective when it comes to the language. So earlier, the people used to do Hadoop MapReduce computing, or should I take, Manoj, can I take this question once we are done with the both architectures? I think this question I should take once we discuss both the architectures. All right, that'll be easier for me to answer then. Remind me in case I forget. Okay, a question is, does the clouds are handled with big data architectures? Yes, some of the clouds are using the big data architectures in the backend. For example, the BigQuery from Google is actually a big data architecture. Similarly, S3, for example, is a big data architecture in the backend, and so on. Okay, question from Bindu is, big data has gotten popularity in recent years. Why wasn't it used before? Okay, so data was there, and people were doing the big data computing. Say, for example, in 2004 at DE Shaw, when I was working at DE Shaw, we had a cluster of 10,000 nodes. Yes, 10,000 nodes. If you are not aware of DE Shaw is the company where Jeff Bezos, the founder of Amazon, was working before DE Shaw. And there we had a cluster of 10,000 nodes. And we were basically distributing our computing across the cluster. And we were using some form of maps and reduces. Maps and reduces is a quite older technology terminology than Hadoop. Okay, so at that point of time, we used different forms of computing over the cluster, and we never used the term big data. Big data became popular in recent times after Hadoop came into play, after in few papers from Google, the term obscene big data was used. Okay, and that's where the term big data came into play. A question from Abhilek is, how is data security related to ensured? Okay, how is data security related to in big data, as well as how it is ensured in big data? Again, it's a big question to answer. There are multiple layers of security um, in 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 case of big data storages. So you generally strip off the valuable information or the confidential information and keep it in different places in isolated place. That's just very quick answer, but the answer would be really big. So I would love to see this question on the forum, and I would love to answer this in far more detailed. Okay, because something which I'm passionate about is secure programming as well as the distributed computing. So this question is something I would like to answer in detail. A question from Gaurav is it important to know about big data before exploring AI? Okay, so before exploring AI, what you need and must know is machine learning. That's for sure. And whenever you require that distributed computing, then you can come back to big data. But there is no path. It's not mandatory as such for learning AI to know about big data. But for learning AI, you require knowledge of machine learning as well as deep learning. And of course, when you do the machine learning, deep learning, you will need to clean up the data and do the distributed computing on raw data. Okay, say for example, I'll give you a very very simple example of my own work. Okay, I'll give you a very simple example of my work at InMobi. So the kind of work we did was we were building the recommendation system. which is basically a machine learning kind of application. We were using Mahat that time. So it is a machine learning application. Now, when you think about the application, it's just machine learning and hence it's an AI, but we were we wanted to give really good recommendations. So instead of running our recommendation system on a smaller sample, we ran it close to 200 terabyte data. Okay, so to give really good recommendations, we ran the recommender on 200 terabyte data. Now, to run it on 200 terabyte data, we needed a lot of big data computation because 200 terabyte data needed to be cleaned and we had to filter a lot of information before being fed to a distributed architecture like Mahat. Okay, and at that point of time, we realized that we would have to do it on Hadoop, and therefore, therefore we had to learn the big data computing, and that was my first interaction of Hadoop. In order to solve a recommender, we had to do entire thing in big data. So in many ways, you must learn the big data processing for many machine learning applications. Okay, but I wouldn't really say that there is a strict path. Okay, so it all depends on the kind of problem you're trying to solve. And also please note that no matter what you do, if you are in machine learning domain or an AI domain, what you will find is that 90%, 95% of the time goes in cleaning the data, arranging the data, and understanding the data. It's only 5% time goes in the machine learning or AI work. All right, good question. I hope that answers your question. There are three more questions I'll take. A question is the storage or processing a lot of data or both is done in big data? Both. Okay, we will learn both. Actually, we'll learn the entire we'll learn the entire mechanism of storage and processing as part of this course. Sarika's question is, can you explain data security handling in fast computing processors? I can ask this on CloudxLab. Yes, please ask this on cloudxlab.com. I would love to answer it tomorrow in greater details. Can we use big data if it doesn't have large volumes, velocity, or variety? So if you don't have large volumes, velocity, or variety, you don't need these architectures. You do not need Hadoop or Spark or NoSQLs or any of these big data systems in order to solve your problem. If the data is neither data is small and is not moving really fast, or is not too complex. So you can actually use the usual tools, say for handling the processing of the data. You could use, if the variety is not there, the complexity is not there, you can use SQL and so on. And all these three can be handled very well with the database. Okay. All right. Bala's question is, what is the best file format to store the data? And string, JSON, or XML? It's a really, really hard question. And here the way we have wars in the programming language, in the same way we have these wars in the formats. Okay, so while XML is really huge, but it's easier to parse, but for big data, XML is generally avoided because it has starting tag, ending tag, and that takes too much of space. JSON is, yes, good, but good for semi-structured. But if your data has fixed set of columns, right? There are many more formats than these, right? Say, for example, Thrift has its own format. Protocol buffers is another one. Avro is another. Paraquay is another. And you will learn more as part of this course. Okay. So there is, when it comes to format, it's not really, neither of these are basically great formats. A string could be, okay, but again, you'll have to design your format. You will have to design your format in order to keep a data either in string format or in binary format. Question is, will you provide any real-time hands-on project? We do provide hands-on project as part of this. And it's not real-time, meaning it's not for a customer from somewhere. Okay, those who really perform well in the course, we generally involve them with our industry projects. Okay, say for example, there was a project from Dell that we have published on the website, dashboard real-time analytics dashboard. And the current one, we are working with um, one of the hospitality providers in order to do their email processing. And so those students, like for example, my student called Nitin, who is now working with me on the real-time project. So that way, we involve many students in our project if they really do well in the course. Okay. A question from Raj, what are the challenges you see while working and accessing on big data? The understanding of big data in very simple. And the challenges is a lot of time goes in the transport, which we never expected as compared to the small data. Okay. Sanjay's question is, for a big data developer profile, do we need to learn BI tools? Not much, not much. But if you know BI tools or SQL, it's always a big advantage. Because big BI tools, say BERT or Tableau, is a presentation tool, and that is generally required in any kind of data engineering. Question from George, what's a good way to compress data for storage? So there are many compressions. There are many compressions, and you will learn that the compression itself, there are three criterias when we talk about compression. Okay, and that three criteria is what defines the good way. The first criteria for a compression is taking some data and converting into some other format so that it takes lesser space. And how does it happen? Removing the duplicate uh, strings, removing the duplicate data and replacing it with the symbol, which takes a smaller space. In very simple words, that's what is compression. Now, question is, what is a good compression? What is a good compression? It depends on what we are trying to achieve. Good compression has three criteria in general, as we'll study in one of the chapters. That first, the compression is the how fast can you compress or decompress? How fast, how much time does it take? Second is, how much can it compress the text data and non-textual data? The third is the compressed data, or is the compression, this algorithm, is splittable? Okay, because in big data, we generally spread the data across multiple machines, and therefore we need a compression which can do the splitting. So in a lot of cases, we prefer a compression like LJADO, which is good for big data, good for distributed architectures, and there are gzip compression and so on. I hope that answers your question. Okay. All right. Very great set of questions. All right. A question from Monica is, if the quantum computers become possible and get global, how much effect it can have on big data analytics? It would definitely have effect on big data analytics, but again, not like the one which we are having right now. Right now, if you have a 10,000 node clusters, they are theoretically performing as efficient as the quantum ones. Also, even if we have the quantum computers, unless we have a complete breakthrough in the storage, unless we have a complete breakthrough in storage, the problem would remain very similar to what we have now. Because the time that takes in the big data computing is about reading and writing data more as compared to the processor. A question from Dharma is that if data exhibits veracity, can we use big data architectures? The answer is very simple. Actually, those three words, I'll be very straightforward with all of you. Those three things, velocity, variety, and veracity, and there's something called value, and there's something called, I mean, people have been adding more and more V's every now and then to that whole definition. I'll be very straightforward with you. The point is that those are just marketing terms. The truth is, when you need to handle humongous data and you cannot do it using a single computer or your usual relational databases or relational usual file systems, then you require a distributed architecture. That distributed architecture is called big data architecture. And as part of this session, this course, what we are going to do is we're going to go into the details of various components that can provide you that kind of big data architecture or distributed architecture. Good question. A question from Manoj. When processing information in, say, 1,000 Word documents, a request to all of you, please read each other's questions. Those are really insightful, and that helps you, you know, understand it better. Okay, so when processing information, say 1,000 Word docs, must data go through ETL and converted into some structured format, or can it be processed directly to get the required output? Okay, so the answer is the first one. When you are, let's say, 1,000 Word documents, and you have your existing tools, can be used on the big data architecture. Let's say instead of 1,000 Word docs, let's say you have 1,000,000 Word docs. Okay, and what you want to do is you want to extract text out of these Word docs every now and then, or you want to create some kind of structured format out of it. So you would be having your own tools. You can run those tools on top of big data architecture such as Hadoop or Spark and extract information on top of these platforms. Okay, the value they provide is they help you in executing this ETL, this logic which extracts data on the cluster. It distributes the processing. Let some 10 Word documents will be processed by one machine, 10 will be another, 10 will be another. And this way, this distribution of work is what we will learn as part of this course. This distribution of work, it takes a bit of time to get used to, and that's why the second half of this course, which is session 12 onwards, we will learn this part. All right. A question from Shakti: is there any disadvantage of big data? That I am not a lawyer, so I cannot say that part. All right. So the only disadvantage is that it might force you to learn new technology, And if you consider that as a disadvantage, also you might have to um, basically get used to new architectures. All right, Bala's question is, how can we use BI tools on top of Hadoop Spark to analyze the big data? So you can actually access either the Thrift Spark server or say Hive server to access, to execute your query on Hadoop via BI tool. That's the brief answer I can give you. If you leave it on, if you leave it on our forum, I'll put the links and a proper example as part of the answer. All right. The forum is on, I'll just show you quickly. I'll just show you quickly and not here. I'll just show you quickly. Okay. So if you go to cloudxlab.com, all right, I'm not digressing, don't worry. Okay. So you can go to discussions and here you can answer your question. All right. Okay. So I would love to answer this question and there in far more details because it'll require me to give you more and more links and the right information. Okay. A question. Let me see if it is visible. Mm, no, Manoj, I do not see that on your side. All right. So the previous question, yes, I did answer your question. Okay. Question from Amkin is, if we use distributed storage rather than distributed computing, wouldn't be better and more efficient? The answer is both. You cannot use distributed computing so efficiently if your storage is not distributed, right? Let's say you have distributed computing, but you have kept the data on one machine. And for computing, you need to take this data to all these machines, and therefore, the two things, storage and computing, go hand in hand. So instead of carrying data from carrying the code only, sorry, instead of carrying the data from one system to another for processing, we take the code, the logic to the data. Therefore, distributed system as well, distributed storage and computing go hand in hand. Distributed storage is using the HDFS in this course, and distributed computing is using Yarn, MapReduce, and Spark, Hive, and all other tools. We'll talk about it and you will learn together. A question is, can you help me understand the role of software QA engineer in big data? So whenever you build systems, you cannot build any kind of system without doing its QA. Any kind of big data engineering work or big data development work would require QA. Therefore, it would be necessary for QA engineers to know how does the Hadoop work, how to test various Hadoop services, or how does Spark work, and how to test various Spark services, and whether we are able to achieve what we wanted to achieve using Hadoop and Spark or the data engineering or not. Therefore, the QA engineer's role is very significant in or any software engineering field. Sarika, I did not get DDI technology. All right, wonderful set of questions. Now, let me go a little bit more details. the kind of questions you are asking is basically signaling me to move on and move to the next point. Oh, I just copied the URL and sent it to only the panelists. Okay, I'll just send it the link to everybody. Okay, that's the discussion forums link. Now moving ahead. Now, when we say computing, when we say a computer, what does it mean? The computer is made up of largely four components. Okay, it's a very important part that we are discussing right now. It might look very, very lame to most of the engineers, but it's very important to think about the computer this way. Okay, one is CPU. When we talk about CPU, it means the number of instructions that it can process per second is the criteria. When we talk about CPU speed, it means the number of instructions it can process per second. Okay, instruction is an order saying, do this, take this memory to this place, and read this data from here. That's an instruction. Okay. The second component is RAM, random access memory, or we simply use the memory for RAM. Okay, memory means RAM. And in case of random access memory, the speed as well as size both matter a lot. So you can make your laptop faster by replacing the processor, or you can also make your laptop faster by increasing RAM and then the hard disk. Okay, the third one is the permanent storage. The problem with the RAM is when the computer is turned off, whatever was in the RAM, it goes away. That need to be saved in the disk. For that, we require a disk. There are two kinds of disk, hard disk and solid state drives. SSD is faster, but they are smaller, while hard disks are slower, but they are humongous and cheaper. So then the fourth component that we all forget is a network speed. So when the data is not fitting in the RAM, we push it to the hard disk. If the hard disk is insufficient, we push the data to the network, and for the computation, therefore, network starts mattering a lot. Okay, so when we talk about big data, any of these four components, any or at least one of these would become such a bottleneck. Okay, so when the data grows bigger, it won't fit in the RAM. Therefore, we put it to the disk. Then when it wouldn't fit in the disk, we put it to the network, and then it'll become impossible to get the work done in a reasonable time. Okay, so at least one, and let's talk about say a complex machine learning problem. It might take a lot of time just on the CPU, and therefore the CPU will become the bottleneck, and hence, like for example, a Bitcoin to mine a Bitcoin, a lot of CPU speed is required. Okay. All right. So at least one of these components will become the bottleneck. Now, a question to all of you. Which components out of A to F impact the speed of computing? Okay. All right. Somebody saying anonymous attendee. It's easier for me to, if you just put some name, not necessarily your name, just any name. Okay. Point is that it looks like the session is very basic. Okay. I'm not sure why we are talking about computer basics when the session is about big data. Haven't been progressing at all since quite a while. Been 90 minutes and don't think I've learned anything about big data and its techniques. So I would very simply request you that there are all kinds of audience in here, and trust me, you may be a little more advanced, but a lot of us do not really feel the way the computing is done. And trust me, even in the most complex problems that I've solved at InMobi or Amazon or elsewhere, what I found is that this important part, that it's not only the CPU, it's not only the memory, it's not only the disk, that's the bottleneck. It could be any of them. Most of us believe that it's the GPU, CPU alone, but when it comes to big data, any of these components could become a bottleneck. So it's very important to know this, all right? Okay, so be with us. You will definitely like the further session, all right? Engage more and ask more questions. Try to answer people's question and you will like it more, okay? So yes, it's all of the above. It's not alone the memory, disk, and the CPU, and it's also the network speed and all of the above. Okay, great. So basically, all of these components are impact the speed of computing. All right, here are some of the use cases. So far, what we have learned is the basics of the definition of big data. We talked about data, its features, and so on. Now, question is that we also talked about why does it matter now? The answer is that question is, why are we learning big data? Why do we need it now? What is so great about humongous data that we can't achieve by sampling humongous data and doing some kind of logic on it? The answer is very simple. The answer is, more the data, better will be the insights. Let's take a case of recommendations. Recommendations sound like very simple thing, and we have been doing recommendations since our childhood. We have been asking our friends, which movie do you like and which movie I like, and we try to find the similarities and give recommendations to each other. That's exactly the recommendations, and that's exactly most of the recommendation algorithms work, by finding similarity between the users and giving them cross recommendations. All right, so recommendations is one such use case where more the data, meaning more kinds of users, and therefore better will be the recommendations. So if there are many users, the chances are I am more similar to somebody in the crowd, and then uh, I'll be able to learn, I'll be able to get better recommendations based on other users. Okay, so more the data, better will be the insights. Okay, and that's where companies like Amazon or Netflix or others have been able to do wonders. They have been able to, they have been able to generate a lot of revenue just from the emails, just from the emails. And emails containing recommendations or recommendation being displayed on the website. Okay, it's well proven and the numbers are very clear. The better the recommendations, more will be the engagement on the e-commerce website, and hence better will be the conversions. Okay, and recommendations are one thing that started a lot of online competitions. For example, a website called Kaggle was started in order to compete on recommendations of such as Netflix. Okay, all right. So the recommendations, the recommendations are generally generated on big data using the tools like either MLlib or say Mahat. I had used earlier Mahat. Now we use mostly MLlib in order to generate recommendations. For example, we are trying to generate the movie recommendations. All we have to do is format our data in this form. Ratings should be somewhere between 1 to 5, and the user ID has to be a integer, movie ID has to be integer, and then Spark will generate the recommendation in the form. All right. So this is something one exercise we'll do in MLlib. So this is called recommendations. So Spark and Hadoop and these kind of almost every system, including R and everybody, helps you generate such recommendations. Okay, and these recommendations are quite useful in an organization. Almost this is the first thing that an organization adapts adapts to or adopts in order to leverage the big data. Okay, now next example of big data customers is in e-commerce is, say, a use case of A/B testing. A/B testing is comparing the response of the users with respect to two different variations, A versus B. Here you see that 50% of the visitors are seeing this header color as red, while 50% of visitors are seeing as green. So this is variation A and this is variation B. Okay, so but these visitors are converting, as in these people are buying your are staying on your website longer and hence buying what you are selling, and 23% of 100 are buying here, and 23% of 50 23% of 50 visitors are getting converted here, while green color is only giving you 11% conversions. So which one is better? Variation A or variation B? That's right. That's right. And that's exactly the role of data or big data. To be able to take these calls easily, whether to keep the background color as green or red. Okay. The more the data, the better, the more the number of visitors, the better will be your A/B testing. The reason, so even the color of Amazon's buy now is a result of A/B testing. Okay, the color of buy now is the result of A/B testing, and this is exactly. It's not something hypothetical. It is something that's done in industry. The A/B testing comes from the drug testing on the field that that some of the users were given just the pacifier, not the drug, while the other patients were given the drug. And then the behavior of both was compared, and that's how drug testing was done. And that's where the A/B testing come from. And A/B testing is aggressively used in e-commerce, in improving your website, improving your emails. Yes, A/B testing is a standard term. Okay. A/B testing is a standard term. In Amazon, we call it web lab, and elsewhere it's called something else. Okay. So basically, the A/B testing is used in the cases where you have enough number of visitors. If you have hardly 10, 15 users per day, you can't really give a better results. The more the number of visitors, the better is the conversion. Okay. Otherwise, if we do not have this kind of data, we will lifelong keep on fighting for the colors. Okay, that no, I like the color red, and the boss says green, and so on. So it's easier. It's far more easier to compare the numbers. Okay, and that's where the A/B testing comes into play. On Amazon, if you open the website and I open the website that you see would be different from what I see, because some of the features would be shown to you, not to me. Some of the colors will be different to me. The location, the position of various element could be different for me. Okay, and we do that A/B testing very aggressively at various levels. So, same is the case with Facebook and Google. Google trying to show the results and trying to analyze whether user like this kind of results or that kind of results. Similarly, Facebook, whether user like this kind of photo, that kind of photo, and so on. All of those features, content placement, everything is aggressively A/B tested. All right. This is where the big data platforms come into play. Then there are many other sectors, such as government sector for fraud detection, cybersecurity, welfare, and justice. And telecommunication, customer churn prevention, network performance optimization, calling data record analysis, and analyzing network to predict failures. Okay, so in telecom, you will be amazed to know that almost everything is of big data size. Say, for example, last year, somebody came along and wanted one project to be done in order to manage the configuration files of each towers. And I underestimated the problem at that point, and I said that let's take a look at the data. And then we realized that every configuration file was around 10 gigabyte size, and it was an XML, and it had to be loaded and processed. And it was basically growing at a very faster pace. So there were around 10,000 of such files of each of 10 to 20 gigabytes and so on. So whether telecom, government, everywhere, there's a humongous data, and hence almost every problem that you see there related to the data is actually the big data problem. Most of them, they have been surviving through, in some use cases, they sample the data and either just use the recent data and so on to resolve it. But in most of the situations, the the organizations have moved or are moving to the big data architectures in order to solve their problem. Okay, now the healthcare and life sciences. In healthcare and life sciences, again, everything is of humongous size. Whether it's about information exchange or gene sequencing or even the healthcare improvement, as in taking care of the patients and taking care of the hospital equipments and everything, everywhere, the data that you get, it would be of humongous size. So even in the drug safety, again, the A/B testing is done on a very large scale at a very aggressive pace. A question is, why do we use, what is the use of uh, data, big data in justice? Okay, all right. Actually, the whole system, if you take a look at some of the R packages of say justice system and psychology, you will understand that almost everything is related to data. Okay, even in justice, you have to track back so many changes and versions and so many cases that are happening all across. And in the past, there there- there's a humongous need of using the big data kind of platforms. All right, I hope I answer your question. A question from Manoj, does it relate to AI then? Okay, so to be very frank, AI is artificial intelligence, the intelligence shown by machines. Okay, that's the generic definition. And that also means that it would, anything that human does, anything the computers are doing is actually what human was supposed to do. And hence, everything is AI in the end. All right. Therefore, AI, we should not use the AI in the terms as in the technology way. We should use the term in the very, the general discussion way. Okay. So AI is basically intelligence shown with machines, and the definition of intelligence is again very, very, very wide. All right. All right. So these were the big data customers that we talked about. Now, there are many big data solutions around. Okay. Some of them are either the hosted solutions like Google Compute Engine or AWS, or say the solutions from Microsoft, right? Azure and SD Insights, or from IBM. Okay, so those are the hosted solutions, and there are solutions which you might want to install. And examples of those are systems like Hadoop and Spark, or Cassandra and MongoDB. All right, when you want to handle big data, you can use many different kind of solutions. And as part of this, we are going to talk about these two. All right, so let's start with the discussion on Hadoop after the break. Let's take a break for 10 minutes, and back by 9:51 p.m. IST. Okay, you can post the time zone in your own time zone. You can post the time in your own time zone. So for me, it'll be 9:51 p.m. All right, all right, great, great to have all of you back, and we will be starting with the understanding of Hadoop, the ecosystem. But before that, I would like to answer this question. Question is, what is the difference between big data and data science? Okay, data science generally involves the basics of data churning. Okay, I'll just put it here. I think that'll be easier. Okay, and all right, can you see my screen? Instead of blankly talking, let me explain. So data science involves the basics of computing, right? And you should know like data processing with using databases, then data presentation, okay, using say BI tools. And data science also involves statistical inferences, statistical inferences, and then few more uh, basics of machine learning is also part of the data science. Okay. Now the second question is, what portion of knowledge in data science is required for a big data architect? Okay, while the presentation is something we assume that you would be knowing, we would give you the basic idea about the presentation of data. And SQL is also something that we would be expecting that you have basic knowledge of, while statistical inference and the basics of machine learning is something that's not required for big data processing, or big data architects, or big data engineers. All right. Good question. I hope I was able to answer the question. Great. So the next question is, we briefly talked about that because of connectivity and devices, we have been able to achieve a lot of problems. We have been able to achieve a lot using technology, and therefore to achieve while we're trying to do that, we need to handle a humongous data. And there are many ways to handling humongous data. Some of the ways are a combination of Hadoop and Spark, which is what we are going to discuss further. All right, so what is Hadoop? Hadoop is essentially a software that was created by dog cutting. It was basically dog cutting and uh, Mike Caffarella, they were trying to build a basic search engine called Nudge. They were trying to build a search engine called Nudge. And for that, they realized that it's impossible to store the data from World Wide Web using existing file system or using existing databases. So at that time, they were kind of stuck. But lucky for them, Google published these three papers: Google File System, Google MapReduce, and Google Bigtable. These three papers provided the groundwork for their Nut search engine. So, so Mike and Doug Cutting, they started implementing these three papers, and that's what became Hadoop. Google File System, GFS, became Hadoop File System, Hadoop Distributed File System. We call it HDFS. Google MapReduce, they implemented the paper, and it is called Hadoop MapReduce, while Google Bigtable became HBase. Okay, so this is what got Hadoop started. It was named after toy elephant of the one which dog's kid was playing, and it was open source. Now this is a very important thing. So the reason why there were many other people who were trying to implement these papers, but since Hadoop was open source, that too Apache open source, that means that you can use it commercially. You can use it for education, research, and um, you can even sell the solutions around Hadoop with the Apache license. Okay, so the Apache license is probably one of the most liberal licenses around, and that's what got Hadoop the popularity. It was Hadoop is considered as very powerful, popular, and supported. Powerful because it has the full. It started with three components: file system, MapReduce, and Bigtable. But today, it's an entire suite of components. Okay, entire suite of software. We'll discuss those software in details. And it's a framework to handle big data. It's a framework to handle big data, meaning it's a framework for providing you the distributed computing. Now, every component under the umbrella of Hadoop is distributed, scalable, and reliable. Distributed means that that whatever component, whatever software which is there under the Hadoop umbrella, be it file system, be it Hadoop MapReduce, or be it HBase or any other tool, all of the tools run using many machines. That's what it means by distributed. Okay, all these tools solve your problem using multiple machines. Okay, now the second is the scalable part. Scalable means if you have 10 machines today and your Hadoop is working fine on those 10 machines, tomorrow as the load is increasing, if you put more machine in the network, your existing system will kind of expand to fill in the new machines. Okay, meaning Hadoop you can keep on adding machines to Hadoop without having to restart or without having to pause the computing. Reliable means if some of the machines go dead, some of the machines do not work correctly, still Hadoop will work fine. Okay, that's reliable computing. So distributed, scalable, and reliable. These are the three criterias for any components to be under the umbrella of Hadoop. So Hadoop started with three things, but now it has become an umbrella of components. Now, question from Manoj is, what's the relationship between Apache and Hadoop? Apache is probably the most used license globally. Apache, Apache started with a web server long back. Most of the websites around the world are hosted with a software called Apache server. Okay, so Apache started as a individual server, but then it became a license. It became an open source license. That means that if somebody is accepting the same license policies at Apache, that means that it'll be as liberal as the usual Apaches. So Apache is basically a license now. Under this license, you can apply for Apache license, and then they will accept this license after reviewing the utility of your tool, and then it will become the part of your software will become the part of Apache. And that's how Hadoop also became part of Apache. And now under the Hadoop, there are other softwares. So that's the kind of open source ecosystem is. A question is, what kind of real-time problems can be solved with big data? Please give you example and why big data is right solutions for these cases. I think this part we have already discussed before this. Real-time problems almost anywhere where the data is humongous and you really need to solve those problems. In those cases, you can use these big data solutions, right? I would say that the big data is nothing but bigger data. So whatever problems that could be solved with any data are solved using big data. Just that when the data grows bigger, it becomes difficult to use existing platform, and that's where we use big data platforms. So big data is not really something new. It's just bigger data. All right. All right, great. Let's move on. And most of the components which are under the umbrella of Hadoop are written in Java. All right, so there is one component that we have not discussing here called Zookeeper, but that will be covered in the course. Okay, so these are the various components, or you can say some people refer to this diagram as the architecture, but it's basically a stack of components of Hadoop. All right, so here the most important part is this file system. Okay, this is the file storage. So if you have many computers, you install Hadoop distributed file system so that you can utilize many machines for storage of many machines for storing your data. You don't have to keep on dividing data on multiple machines. Hadoop distributed file system will provide you a single big folder in which single big file system in which you could keep on putting the data, and internally it will keep on dividing that data on multiple disks. Okay, so that's Hadoop distributed file system. We'll go into more architectural details in the course. Now, since the data is distributed on many machines, you want to process this data using many computers. So it will be better that if we process this data that you divided on many computers, then and there on those same computers, and that's where yarn comes into play. Yarn lets you execute any program, or yarn lets you build these softwares that can be run on multiple machines. So yarn is a big resource manager which keeps track of what's going around on all the machines and accordingly executes your program on multiple machines. Whether Spark or MapReduce, everything can be executed on top of Yarn. Yarn, when you think about Yarn, you can think of something that's not going to interact with you much. It's going to interact with the next level of softwares. So Yarn provides you kind of a distributed operating system on which you can run programs, and those programs will be run in the cluster. Okay. Now, the next in the line is HBase. What is HBase? HBase is a storage of structured data. We also call it NoSQL data store. Okay, so even though we have a file system is used for storing data in the form of files and folders, right? The file system is used for the files and folders, right? If your data is in the form of records and you would like to store the data in the form of records and you would like to edit it from time to time, then you use HBase. HBase is great for the data that has more than millions of records and more than thousands of columns. Okay, if your data is lesser than say 10 million records, you should continue using relational databases. Okay, then comes the compute engine. You cannot, for every work, you cannot really sit and write a software that can work on Yarn, and therefore MapReduce is provided. You'll have to write the code for the MapReduce, and to avoid that, there are other tools. Okay. Similarly, there is Spark. Spark also runs on top of Yarn, and almost every compute engine that can run on Hadoop runs on top of Yarn. Okay. So if you are coming from SQL background and you would like to do processing on big data, you can write the whole processing in using SQL. You can do if your data is in a structured format, as in table format, then you can do the entire processing using SQL interface via Hive, and you don't have to write any kind of code. The next one is Pig Latin. Pig Latin is similar to SQL interface, but it's not used much. All right. The next one is if you are trying to do the computation, larger computation on uh, if you're trying to do machine learning on big data, Mahat used to be the solution, but most of it has moved to Spark. So this component and all its dependencies have moved to Spark nowadays. And therefore, in this course, we will discuss this less, the MapReduce less, and we will discuss Spark more. Okay. And when you have a big project, say, for example, you are trying to build your own recommender, you are trying to build your own say a software that could do real-time analytics or could do the sentiment analysis. If you are trying to do that, you will have to have many components. You will have to have a combination of these components in your solution. And to get your work done using these solutions, you use a tool called Oozie, right? Oozie lets you create a workflow in which you execute this, then execute this, you can work on this, you can work on this, then you work on this, and so on. So instead of you trying to execute manually, you let Oozie execute these in a sequence. Okay. Also, there is Flume and Scoop. What is Flume and Scoop? If you have a lot of unstructured data, let's say that your web servers are running and you want to continuously pump this data from many machines onto a central data lake. Generally, HDFS is also used for data lake purposes. What is data lake? Data lake is a kind of central place where the data from the entire organization comes to. So if there is a lot of unstructured data and you would like to pump it continuously to Hadoop distributed file system, you can use Flume. Okay, if you want to do it continuously, meaning as soon as the data is available, you want to push it here. Now, if you have your data in relational databases, you will have to import it into Hadoop file system or HBase or Hive. You can use Scoop. With Scoop, you can import or export data from relational databases into Hadoop ecosystem. All right. Now, let me, before proceeding to Spark, so most of this part, most of MapReduce work is being replaced with Spark. So the same is in our course. The earlier we used to have around 4 sessions on MapReduce alone. Now we have reduced that and made it only one. The most of the time we are spending on Spark. Okay. A question from Manoj, all these softwares have to be installed on each machines of distributed network? Yes, yes. So not all, we will learn that part also. Not all. Some of these components only need to be a single instance and therefore not all on the machine. So HBase master, for example, master will be on one machine, slaves will be on many machines and so on. Similarly, in case of Hadoop file system, there will be one master, many slaves. Okay. A question from Hitesh, does Hadoop divide my data based on different features of data? No, no. Hadoop, as in Hadoop distributed file system, when it divides the data, it breaks it down based on the size. Okay, that's all. Now, coming back to the another good ecosystem is called Apache Spark. We talked briefly here that it runs on top of Spark. Let's talk about this. So second part of this course that we are talking about is about Apache Spark. Spark is a fast and general engine for large-scale data processing. So Spark is only for processing. Spark does not provide any storage. Spark does not provide any storage. Spark just provides a way to do the computation in a distributed fashion. Okay, so it's basically really fast MapReduce, and it's 100 times faster than the Hadoop MapReduce in memory and so on. Okay, it's very well integrated with Hadoop. It builds on similar paradigms as MapReduce. Okay, so let's talk about the ecosystem of Spark. Spark, what it does is it lets you run your program in the cluster. Okay, it can run on top of Hadoop yarn. If you don't have Hadoop yarn, if you don't have Hadoop installed in your organization, you can use Amazon EC2. Otherwise, you can, if your organization is using Mesos is similar to Hadoop yarn, then you can then also you can use Spark. If none of these three are available, then you can install Spark in a distributed way using the standalone resource manager. This is called the layer. We'll go into more details about every component. So Spark can read the data from all of these sources. You can read the data from these sources, whether your data is located in a Hadoop file system or Hadoop HBase or Hive or Tachyon or Cassandra. Also, the core Spark core can be used with Python and Scala. If you want to use the more complex computing, you can use these packages of Spark. Data frame is a package from Spark. Streaming is a package from Spark. MLlib is a package from Spark. And GraphX is a package from Spark. Data frame is great when you have the structured data that you would like to process. The that data is in the form of SQL. If you want to process the velocity part of data, whereby the data is coming continuously and you would like to process it then and there, then you can use Spark Streaming. And if you would like to do the machine learning, as in the complex computing, in order to predict based on the past history, then you can use MLlib. MLlib is a sophisticated machine learning library that runs use on many machines simultaneously. Therefore, MLlib is far more efficient than any other machine learning library. The next one is GraphX. GraphX is a graph computing engine. Okay, when you want to do um, graph computing, let's say on Twitter, you want to do an analysis, who's a thought leader, you will have to process the graph. If you have a Facebook group and you would like to process that Facebook friend network, then you will have to do graph processing. So the complex computing part, the variety part is what you can handle with these two. The velocity part of data is handled here, while the storage is generally handled using the HDFS and HBase. Okay, the storage part, the volume part is handled using the HDFS and other parts. All right. So Spark provides your holistic ecosystem for the computation. Okay. Now you can use any of these programming languages. So let me answer your question. There is a question called you did not say anything about Python, Java, which figure on previous, right? So here you can see that. All right. So far what we have learned is in the previous figure, let me talk about programming languages. You can see that here to interact with Hadoop file system, you can interact either using Unix commands, using Java API, using REST API, probably almost every language. Okay. Similarly, to interact with that space, you can use any language. To interact with Hive, you can use any language. Same is the case with these. Therefore, any programming language you are comfortable with, it should be okay. For that matter, MapReduce, even though I am a good Java programmer, I'm a good Java programmer. Still, we did MapReduce using Python. Why? Because it was quicker to do. So, so when it comes to data, I would strongly recommend that you either go with Python or kind of Scala. Okay. So what I'm trying to say is even with MapReduce, even though it's written in Java, we were able to do the programming using either Unix shell or using Python and even R on Hadoop. Okay, so don't worry about programming language too much. Okay, the war between the programming language is kind of over. You can use almost any programming language. All right, so and be ready to learn a new programming. That's my advice to all. Be ready to learn a new programming language whenever it's needed. But you just need to learn at least one programming language so that you can quickly move to a new one. Okay? It's not necessary to know every function, every construct of a language. It's good enough to know the basics of a language. Okay? All right, now here is an interesting part with respect to Spark. So you can actually do Spark computation. You can do all of this using SQL, R, Java, Python, and Scala. All right. As part of the course that we are talking about, this course will focus a lot on this course will focus a lot on understanding distributed computing. And second part, we will learn Spark. And in that, before going to Spark, we will have dedicated 2 sessions on, on Scala. We will be doing the computing using Scala. And I'm sure in case you are from Python background, you will be able to use the same commands, similar commands in Python as well. So there won't be any problem at all. Okay, so whether you're using Perl, Python, or Scala, or Java, or SQL, or R, you'll be able to use them. Out of this, since Spark is written in in Scala, that's why people generally want to learn Spark with Scala. Okay. Question from Manoj. Suppose one is good versus with all of the is well versed with all these languages, then which one should be used preferably? Here we'll be going with Scala. Okay. But I generally suggest people that you you should also be a little familiar with Python. Okay, that's kind of a Swiss Army knife. You can use that in many circumstances. All right, but Scala is also kind of equivalent of Python when it comes to constructs. So you will not have much problem in using Scala. All right, so here in this course, we will learn Scala and then we'll be using that. All right. Okay, so any questions here? A question from Bala. Why Scala is used to build Spark? What is the advantage gained with Scala? Okay, let me explain that part. Okay, the question is why Scala is used to build Spark. To be honest, it is kind of their personal choice. But since Java is, as per them, they wanted to make a really performant one, and Java seems to be good performant one. So, so they chose Scala. Why? When Scala compiles, it compiles to the intermediate language, same as Java. Okay, I think I can just take a little digression. We have a little time. Okay, so I'll just draw it here. So Java is one programming language. When you compile Java, right, it compiles to something called Java bytecodes, okay, which is in the form of .class, .jar files, okay, and this can be run using Java virtual machine, okay, this can be run using Java virtual machine. Java virtual machine is a program that can run it. So you write your code in Java, which then you compile it and then you give it here. Okay. Now let me just take a little bit digression. I think this is important. Now the next question is that what happens in case of Scala? Again, Scala is a different programming language, meaning the syntax is very different from Java. But when you compile it, it compiles to it also compiles to the Java bytecodes, okay, which can run on JVM. So if you write a program in Scala and you compile it, it will basically be able to run everywhere wherever Java could run. So, and Java can run almost on every device possible, okay. Therefore, it was a very nice choice. Now, problem with Java was that there was no interactive shell available. Okay, there were many tools were not available as part of Java, and the syntax of Java was too much tiring, as in you had to type a lot, and therefore Scala was a better choice. So the code that gets compiled here is actually faster than the normal Java because there are a lot of optimizations that are done as part of the compilation. Okay, so it's an important design. The other thing is that your Java program can depend upon your Scala program, okay, can depend upon your Scala program, and your Scala program can depend upon the Java program. So whoever has written the libraries, like there are various kinds of libraries available in Java to access database, to draw graphs, to do every kind of things. There are libraries available to do encryption and so on. Those same libraries can be used as such in Scala. Similarly, if you are writing a program in Scala and somebody else is using Java, they can use your bundle and use your functions right away. Okay, so that's the reason why Scala was a good choice. Okay, it gives you a little better performance than even your usual Java, and compared to other languages, Java gives a decent amount of performance, say compared to Perl or Python. Compared to Python, the Java as well as Scala gives you little better performance, but that performance is hardly the reason for this. Okay, I hope that I answered your question. All right. Now, a question from Shubham is that what is Zookeeper? Okay, what is Zookeeper? We will learn this in the second session. Okay, so as I told you that I'll just give you a diagram here. I don't want to go into much detail. When you have many computers, right? And these computers are doing something. They all are doing something here. And okay, they all are doing some kind of processing and they want to coordinate with each other. So instead of talking to each other like this, they kind of talk to a central agency. And this is where the zookeeper come into play. So they kind of inform the central agency and read from this central agency. Okay, so they write to and read from. It's kind of a central database for storing smaller information. This is Zookeeper. Okay, so almost every component that you see it here, every component, what you see here, like HBase uses Zookeeper, Hive uses Zookeeper, and even MapReduce can use Zookeeper, Yarn uses Zookeeper, and Spark uses Zookeeper, HDFS uses Zookeeper, and and even non-Hadoop components such as say Kafka is a queue, they also use Zookeeper. Zookeeper is an independent component. And all right, I hope that answers your question. I'm not going into much detail. I just wanted to give you a broad perspective. All right. Our question is, what is the best way to choose right combination of big data architecture? All right. Uh, Really hard question to answer. Let me try to answer this. Feel free to ask the question because okay, even if you want me to go over certain topic again, I can go over. We have some time. Okay, I'll take you through a CloudxLab overview after this. Okay, all right. Now, what is the best way to choose the right combination of big data architecture? Now, there are many components. What you see here, there are many components. There is Hive, HBase, and so on. The best way is to know about components, okay? To know about components, do a little hands-on on the components, okay? That's the first thing I would request because what I found is that whenever people, you know, learned about these components, their perception of any of these was very different from what it is. For example, the other day I was discussing somebody, then he said that we can use Spark for in-memory computing. Okay, not really. Okay, therefore it's important to know these components first of all. Okay, first of all, as in at least do one hands-on with them. Then Then second thing you need to do is you understand your problem, understand what problem do we want to solve, okay? And you will be able to decide. And that's kind of, you know, the purpose of this course, that by the end of this course, you will be equipped with the knowledge of these components and how to use, how much effort will it go to use individual one, and you'll be able to take the calls related to the architecture instantaneously. That's the reason why we will make you acquainted with the entire ecosystems, with the tools that are going on, and you'll be able to take the decisions yourself, because every question that you will face afterwards could be very different, and you might have to choose between many ecosystems. All right, but this course will give you a good enough idea. Question from Subham is, Zookeeper makes coordination between machines. It it runs at a one place, just like the databases, right? They run on as a service, and it's up to the people who are using Zookeeper to use Zookeeper for coordination. Okay, the purpose of Zookeeper is to help you in coordination by providing a folder-like structure for storing data and providing you various kinds of ways, such as identifiers, ID generator, and so on, in order to coordinate. All right, we'll go into more details, and this is something which is available on the website. Even if you're not going for the course, you can go through this topic. All right, I will do a little hands-on after this, as somebody is suggesting. All right. So here we have, so if you go down here, one is that you must go through the Linux basics. Java Essentials is up to you totally whether you want to go with it. And Big Data Introduction is the same class what we're having right now, is the same one recorded in the studio. And then you have Zookeeper. Okay, you can attend to Zookeeper. In Zookeeper, we basically talk about the entire, entire thing in the detail. Okay, why there is a coordination required and so on. Okay, so and we will basically go over all the details of these. Okay, and in case you are just trying to see the live example, this is one use case that you should go through. This project is 14 page project in which you will be able to do a real life project. Okay, so this is something you could do. We have provided some amount of content on our website for free. You could take a look at that. And for the deep dive into the entire course, you can come over to our live sessions, or you can buy the self-paced one. Okay. Now most of the things that we learn in this is basically understanding the entire ecosystem and when to use what. All right. Question from, okay. So a question is, will you show us a live example? I can take you through a quick example of the source code, quick example of say word count on Spark. Okay, and I can actually give an overview of our lab that will give you an idea of these services what we are talking about just now. Okay. Question from Afghan is that, do all these things are a single installation, or do we have to install them separately? You can do both. Okay, so Hadoop is, there are a couple of vendors. Okay, there are a couple of vendors of Hadoop who basically provide support around Hadoop and also provide some customizations around Hadoop. The two of them are Cloudera and Hortonworks. Okay, they basically provide you the they basically provide support around Hadoop ecosystem. Along with that, they provide these small tools such as provisioning tools to help you install to help you install Hadoop in your cluster. Okay, and they basically help you install in the entire. entire cluster automatically. So you do not have to install them separately. You can use, say, Hortonworks or Cloudera installation, and you'll be able to install that on multiple machines. Okay. So now, session is not over. We are just going to go over the lab. Okay, a question from Abhilek is that, do you provide a lab environment which we can practice after completing the course? Yes, that's the whole purpose of our, actually, the existence, honestly, because we are kind of pioneers in the cloud-based lab. Okay, and many people in the industry are using our lab also for their own students and for building their POCs, POC as in the proof of concepts. Okay, so when you sign up, when you enroll for the course, you will get 90 days access to the lab. Also, you can buy the lab separately as well, and you can go to the lab credentials, and these are the three components we will talk about. One is Ambari. What does Ambari do? Ambari gives you a interface. I'm going to log in into admin to just give you a picture of it. Okay, Ambari gives you a way to install the cluster. Ambari is an installation component or a tool provided by Hortonworks in order to help you install the cluster in your network. All right, but we have installed it for you. You don't have to install it for learning purposes, but if you, for your organization or for your production requirements, you might have to install the Hadoop in your ecosystem. All right, so what you see is there is HDFS, the Hadoop distributed file system, and the services. Then we have Yarn, then we have MapReduce on top of it. We have Hive, HBase, Pig, Scoop, then Uzi, and Zookeeper, and so on. Okay, there's a Flume, and this is running, it's just showing it wrong. Okay, and all right, we have Mahout as well, and then we have Spark. Okay, so we have the entire ecosystems installed for the candidates. All right, a question from, okay, there are three questions. All right, so the other interface that we provide you is Hue. While Ambari was from Hortonworks, the Hue is from Cloudera. So we provide the best of both worlds, and we keep on upgrading the lab in order to provide you the best experience, so that whether you are from data science background, you're trying to do big data along with data science, or you are from machine learning background. So for every kind of background, we have created a central lab in which you can do almost everything. Okay, so here is the interface provided by Cloudera, which can help you do various kinds of works on the various you can execute or interact with various components of Hadoop ecosystem. For example, if you, let's say, want to interact with Hive, you can go to Hive interface and start writing queries and defining tables. Okay, you can start defining tables and creating queries. You see that? So this is what I have done so far, and these are the other tables. Okay, so using Hive, you can start executing your queries. If you are using, say, Pig, you can start writing Pig queries using this. And if you want to create a workflow, somebody's question is, what is the role of Uzi? Uzi can let you create the workflows. Okay, Uzi can let you create the workflow. Let's say here we want to execute something on Spark. So we can drag and drop. We can drag and drop things and create our workflow. Let's say some part of our computation needs Hive. So we can drag and drop Hive here. I'm just going to put, okay. I'm just going to put random things. And let's say before going to Hive, let's say we want to do other kind of processing. Let's say we want to run a scoop script. Then we can just define the scoop script here. Also, if we have say map reduce job and other kind of workflows, then we can actually create the workflow that first do this, then do this, then do this. Here, first it's going to do this. These three things are going to be done in parallel. Okay, I'm going to create this has become a little messy more. Okay, let me just delete it. Okay, let me delete this one, and so on. Okay, so you can actually drag and drop and create the workflow. Like, in what order do you want to do the processing? Okay, that's what the Uzi is for. All right, does it answer your question, Mallikarjun? All right, so and in here you can actually interact with other components as well. You can schedule the tasks so that they can run in the background and so on. Okay, and also you can interact with HBase, you can interact with Zookeeper and so on. Okay, so this is Hue. A question from Bala is that how can I observe the stats of an Uzi workflow, say how much resource for a workflow or a set of workflow is used? The answer is that Uzi gives you a way to observe your jobs. Individual job could take different amount of uh, memory and things like that you can observe from your logs of individual jobs. Okay, so Uzi internally is not running the job of yours. It is actually delegating the work to Hadoop. Okay, Uzi is not kind of running inside itself. Uzi is not running the jobs inside itself. It's running the jobs on third party. Okay, that's where the difference between this workflow and the other kind of workflow is. Okay, because it's going to delegate everything to Hadoop. It's more like Ant. Have you used Ant, Make, or some other tool which lets you run many things in order to achieve the project, or Maven? All right, good, great set of questions. Now this is where you can see what a file system looks like. Okay, this is my Hadoop file system, and though it's hosted, these files might be on different machines, but for you, it's a single beautiful folder. Okay, this could be on some other machine, this could be on some other machine, and so on. And here in our lab, you must have seen there were these many hosts. If you go into host, these many hosts are there in the lab. Okay, so using file system, we can upload, download files, and this is Hadoop distributed file system. Now, next question is, there are two questions related to the same. Question is, what is Kafka and what is it used for? Okay, I'll just take 2 minutes for this. I hope that's not a problem with others. Okay, so in an organization, many services are there, right? Let's say this is one service, this is another service, then this is another. This is maintained by team 1, and this is team 2 and team 3. They are doing their job, right? All these 3 teams are working at their own. Now, team 1 is providing some kind of service to the users, and when the user is coming to the service provided by the team 1, like the way we were working in the Amazon detail page. So if the user is coming to us and user 2 would like to be informed about various activities. Okay, say for example, let me take a proper case. Let's take a case of, say, Amazon. The moment user comes and places the order, they're placing the order on the website, this is, let's say, website team. So user placed an order. Now the email has to go to this user, as well as availability has to be updated. One way is that we keep a tight coupling between them. Let's say this is the email team, okay? And let's say this is the availability team. So either in the software itself, we keep this hard binding that when something happens, inform these two teams, okay? That's the one way of keeping it. While a better way is maintaining a enterprise bus or messaging system. Okay, this is also called message queue. So we install a organization-wide message queue, and what we do is, um, when something happens, interesting happens, everybody writes to the message queue, and people read from the message queue. Okay, so the producers write to the message queue, and then the consumers read from the message queue. Okay, so what happens, let me again take the same case. So when user came to your website, okay, what you did was you connected to the message queue and dropped a message there saying that order has been placed. Okay, now all the people who are reading from the message queue, they will get notified that, hey, order has been placed. Okay, and they can take the further decisions like whether to send the email, whether to send it to shipping team, and so on. Okay, so everybody, instead of this website trying to inform the other teams, it basically writes to the message queue from where everybody can read. Did it make sense to you, Valuri? Okay, so basically this is exactly the most practical use case you can see of message queue. Similarly, there can be many use cases of message queue whereby everybody wants to listen or hook to other person's services. Okay, so yeah. So this is for the cases where there is an organization and there are multiple teams and they want to be informed about activities of one another. Or there could be multiple components of the same software that you would like to run in a distributed manner on multiple machines, and they would like to read from, they would like to coordinate between themselves. Then you can use this message queue. Message queue is like a central database, just that you write to it or you read from it. You don't query it. Okay. I hope that answers your question. All right. So this was our one. So the third component here is we talked about Ambari, which gives you a way to monitor the cluster and provision the cluster. And we talked about Hue that lets you interact with every component. Then third one is normal web console. Okay, the normal web console. This is the web console that you get. You can log into your web console easily, like the way I'm logging in. Now here, this is a proper Linux machine. Okay, anything that you can do on Linux, you can do here. It's just that you do not have admin privileges. Okay, let's say I would like to run Spark here. So I can run Spark shell and interact with Spark to do the computation. All right. So this is what this is the Spark starting up. So I'm trying to connect to the Spark so that I can do some interesting processing. All right. Okay. Since there could be many users at this point. All right. So let's say I would like to create a data set from let's say lines. I'm just showing you how to do some processing. I'm sure it's not relevant to others. Don't worry, don't get panicky because of looking at the code. Okay, I'll just take 2 minutes. So what we are trying to do is we want to read. You see this slide here? You see this slide here? This slide? So we are just showing that Spark can read data from HDFS, right? So what we do is we started the Spark shell. Okay, we started the Spark shell here. And then we are connecting to this HDFS. Now, let's say we want to read a file, say 12 November. Okay, okay. Let's say this file, or let's say, yeah, let me just say this one. Okay, what's the name of the file? The name of the file is 12 November, and all I'll do is go here and say 12 November. Okay, and in order to take a look at this one, I'll just say, show me one line. So it shows that one line is this. Okay, if I say two, it'll show me two lines. Okay, there's only actually one line, therefore it's not going to the second one. All right, so basically there's just one line. So the point I'm trying to make is that using Spark, you can read, process, and do every kind of processing on your data. All right, so we'll go into more details and more slowly. This was a more abrupt demo. Okay, so this was more abrupt demo. You can do large scale computing like processing hundreds of gigabytes of data using Spark. Okay, which you cannot do it using other systems. A question from Bala, can I allocate the node manager to yarn queue? Node managers to yarn queue, okay, such that I can run my production jobs in that queue without running out of. I can answer it separately. I think this will go a little too difficult for others. I can answer it separately. All right. Come over to the discussion forum. Please leave it there. It's a very interesting question, and I would love to answer it in details. Okay, please come over to the discussion forum, and I'll answer there. Great. So these were very great set of questions. Keep the questions coming. So, all right. Using this, you can actually do all kinds of processing. You can perform the machine learning tasks. You can perform the graph processing works, and so on. Okay. And using this console, you can actually learn a lot of things. Let's say you want to learn Python. You can just start Python here. And the basic program I've written is 3 plus 4. You see that? Okay, this is probably the most complex program you must have seen. So this is Python. Okay, and you can define your variables and you can start doing the computation here. All right. So you can do almost everything here. Whatever you can do on Unix or Linux, we have almost every package installed. And if you want to just go for the lab, you will get all of this as part of the lab. Okay. And let me just go over the course a little bit, those who are interested in the course. So we have two courses. One is the big data with Hadoop and Spark, other is machine learning. And so this one is a specialization in Hadoop and Spark. It covers the entire ecosystem that we talked about, and it's compatible with many certifications. Okay. Question from Abhilek is that you mentioned about Google Compute Engine in one of your slides, what it is. Google Compute Engine is basically Google is providing you a remote machines on which you can work. Google Compute Engine is just like AWS. It provides you a way to do computation on the resources of Google. All right. It's a Google's cloud. All right. A question from Abkin is, do we prepare data with big data architecture for machine learning and people? Or machine learning can itself do that using some other tool? No, we do. Using big data architectures, we prepare data so that it can be used in various ways, be it machine learning, be it AI, be it IoT, and so on. So the entire portion where humongous data is dealt with is part of big data engineering. Great set of questions. Keep the questions coming. We have the, okay. So the duration of course is basically they're going to be close to 20 sessions, 20 sessions. And next week being the holiday, okay, so there won't be any class on next week. And the next class will be on 25, 28th, I think. Yeah, next class will be on 28th. So you can enroll at any point. Uh, okay, just that if you enroll now, you will get a more number of hours for the lab. Question is there any alternative software to Spark or the whole thing? So people have tried to build alternative solutions, but most of them are generally incomplete. Say, for example, Kafka itself is providing a computation engine, but it's not as powerful as Spark is. And similarly, there are other alternatives, but most of them do not provide the complete ecosystem. Question from Manoj: when Amazon recommends based on my shopping habits, it is not machine learning. It is machine learning. It is machine learning. These are called collaborative filtering or the recommendation systems. Okay. The recommendation systems are also known as collaborative filtering, and it's part of machine learning. It's kind of statistical machine learning, we call it. But we'll be teaching you how to generate the recommendations as part of this course. Okay. A question from Karim is that any guidance on Cloudera certification? The Cloudera certification, my suggestion would be okay. So the guidance with respect to the Cloudera certification is that this course is designed in a way that you will be ready for uh, all the three certifications, and right. So it's compatible with Cloudera as well as Hortonworks certifications. Okay, so you can see that. Question from Manoj: what's the relationship between ML and AI? Are they totally separate things? So ML is a way to achieve AI, while AI is something very generic. Okay, I think I can share with you some of the videos which I did in past for machine learning and AI. Okay, so I'll send you that video that where we talk about the AI. And okay, so let me just I'm trying to locate if I can find it somewhere. It would be on our blog actually. It'll be on the blog. Okay, it'll be somewhere here. Okay, this one is the one. All right. So sorry, I think I clicked the wrong question. Okay, let me answer the last question. I clicked wrongly. Question from George was that it is necessary to know BI tool like Power BI or Tableau, or it's just a plus. It's just a plus for the course. Okay, it's not really required. All right, great set of questions. I look forward to see you in the session or participate in the forum, and that'll be okay. You come over to this discussion forum, it'll be quite useful. Okay, so great to have all of you in the class. Feel free to reach out to us if you have any questions. Okay, if you are interested in machine learning, this is probably the most complete course, as well as our big data course is probably the most exhaustive course available on Hadoop and Spark. Okay, great to have all of you in the session. I totally enjoyed your questions. There is one more question from Bala. Cloudera Manager versus Hortonworks Ambari versus Amazon EMR. Which would you see as the best, or where do they lead? Okay, let me answer this question. Probably this is the last question. Okay, and all right. Okay, question is Cloudera Manager versus Hortonworks Ambari. They're kind of equivalent of each other. We'll talk about these later. Let's talk about Amazon EMR. So when you just want to execute the MapReduce job on Amazon, then you can use the Amazon EMR. But in case of Amazon EMR, you cannot take the advantage of data locality. Meaning, in case of Hadoop, the data is distributed in the same cluster in which the computing is going to be. Therefore, you don't have to carry around data. You don't have to transport or transfer data across the cluster. The code is taken to the data, not the data is taken to the code in case of in case of usual Hadoop installations. But in case of Amazon EMR, it cannot take the, it cannot take the, it cannot do the processing then and there near the data. Therefore, Amazon EMR is good in case you are trying to process data which is located at Amazon's premises. Okay. While if you have your own data lake, you might prefer either of these two. Either you go for Cloudera Manager or Hortonworks Ambari. We went ahead with Hortonworks Ambari because of our experience in past at InMobi with Hortonworks Ambari. We used the Ambari there, and Cloudera Manager is something that we did not find it comfortable with, so we did not go into that. All right. A question is, okay, so the fee structure, you can take a look here on the website. You will get the clear picture. Okay, so the fee structure is, if you're going with self-paced course, it'll be close to $200. And for the live course, I'm not sure, I'll have to check. Okay, so you can come over to the website and there you can take a look. All right. All right, I'm just pasting the URL of the course. You can take a look at it. All right. So thank you, everyone. It was a great session and great set of questions. A question from Manoj: what are the two courses? So this course is basically the combination of the two, big data with Hadoop and big data with Spark. Okay. And this is the course basically split into two. There are many people who have already learned Hadoop. They may not like to learn it again. In that case, they may just go for only the Spark. That's the reason. Okay. We are learning Spark in this course in details. Okay, so this course is basically a composite of the two courses. Yes, you can enroll for the only the lab access and use that. Okay, you can go to the lab section and you can just go to the lab section and enroll. All right. Question is, what is difference between Hadoop and Spark? Basically, Hadoop is this ecosystem, while Spark is this ecosystem. Hadoop provides the component for storage as well as computing, while Spark only provides the computing component. Spark is an alternative of Hadoop MapReduce. This particular piece, this is what is replaced with Spark. All right. Thank you all for wonderful set of questions. I totally enjoyed your questions. Okay, so feel free to let us know and feel free to spread the word around amongst your friends if they're interested. Great. Wonderful to have all of you in the session. Bye-bye. Have a good day. Feel free to let us know if you have any questions. I'm happy, Mallikarjuna, that you liked the session and found it helpful. We are very happy. Bye, Chirag. Have a good day. Thank you, Akanksha. Have a good day. Bye, Shripad. Thank you, everyone. It was wonderful to have such good questions. Yes, you have raised the hand, Abkin. Thank you, Jose. I hope I was able to answer your questions. All right. Great. Wonderful to have all of you in the session. Feel free to reach out to me or visit on CloudxLab. And at least I would suggest that take a look at the Linux tutorial. It's being used by many people. And okay, so come over to the discussion forum and ask the questions there. I would love to answer your questions. Already there are quite a few questions there. The recordings and the slides will be shared with you all. Okay. Bye-bye. Have a good day. Great. Wonderful to have all of you in the session. Bye-bye. Have a good day.